Yeah. Oh, yeah. And we are live. Awesome. Good morning, good afternoon, good evening. Hello, wherever you are in the world. And welcome to episode 2 of Cracking the Code interview in Rust. This is the second episode of a 3-part series. So if you joined us last week, welcome back. If you're new to this, welcome. Now, this is designed to be an interactive show. So we're going to be working on some code problems. And we want you to be involved. We want you to jump in, give us your thoughts about the problem, ask questions about Rust, hit us up with anything you want to know, get involved, and just have a conversation with us. And because we want you to be involved, we do ask you to adhere to our code of conduct. We're going to put the details of the code of conduct in the chat. We're going to put a link to our full code of conduct. But please get involved with the chat, ask questions, but don't be a jerk. Be nice, be kind, play nice, and we'll have a good stream today. So, as I said, thank you for joining the stream. We are working on cracking code interview problems in Rust. For those who signed up before, you may notice that I have a slightly different guest to the one promised. So, once again, I'm joined by Ryan Levick instead of Nell. Nell is unfortunately unable to join again this week. So, Ryan has joined us. So, Ryan, do you want to say hello and introduce yourself for those who haven't met you before?
Yeah, sure. Hi, everybody. I'm Ryan. I'm a cloud advocate here at Microsoft, and my focus is on Rust. So I should be right at home today as we code along on a problem in Rust.
So, Ryan says his focus is on Rust. I mean, he's part of the board of the Rust Foundation. So, maybe selling himself a little bit short by saying his focus is on Rust. And for those who don't know me, I'm Jim Bennett. I'm a cloud advocate based out of the Microsoft Reactor in Redmond. I'm actually live streaming from the Microsoft Reactor. If you joined my streams before, you're probably more used to Star Wars Lego behind me. But I'm actually in the Reactor today filming. So snuck into a little room to do this live stream. And I've been dabbling in Rust. I don't know much Rust. So I'm really privileged that Ryan has taken the time to join me just to kind of help me, guide me, teach me as we go on this journey. So anyone who's online, jump in the chat, say hello. Let us know if you joined last week. And then we will get going with some Rust. And the whole purpose of these streams is to look at the kind of problems you might get if you do a coding interview. So, like them or love them, a lot of companies, if you're going for a job as a software engineer, will get you to solve some kind of software problem. LeetCode, HackerRank, those kind of things. They will ask you to address some of those. And we're gonna pick a problem, and we're gonna try and look at this in Rust today. Now, just a couple of things. I'm just going to share my screen because it's been one of those days today and I haven't done all the things yet. Hey, Meet the Requirements is back. Hey, Meet the Requirements. Glad to have you back here. And Meet the Requirements has been joined last week and it was awesome. Thank you very much. Very kind of you to say so. And working on a REST API in Rust for a side project. Nice. Welcome. Glad to have you back. Doug Boone says, good morning. Old dog learning new tricks. Glad to have you here. Ogbonna Kingsley, hello. Glad to be here. Crypto Uni asks a good question, actually. Hey, guys, quick question. Does Azure support Rust? I think this is a question for you, Ryan. Does Azure support Rust?
So not directly, but you can run Rust in a custom runtime. So like if you're running it through something like, you won't be able to run Rust directly as a function, but there is support for running Rust, and we have a couple of docs on how to do that. So it's not quite as straightforward as hopefully one day in the future will be, but yes, you will be able to use Rust to run a function.
So I guess things like if you want to run the container apps, for example, you could build a Rust app that runs inside a container, and then you just deploy the container app. So as long as you're bringing your runtime to it, it runs quite happily. But yeah, something which Ryan and I were talking about earlier. So Mark Kusinovich, the CTO of Azure, so fairly senior guy in the company, he's saying that Rust is the future. So I think we're going to see a lot more Rust happening. In fact, if you're into Internet of Things, as some of you may know who's met me before, I am into this. Azure Sphere have just announced Rust support, just in kind of preview, but we're looking at bringing Rust to some of our secure IoT hardware. So a lot of cool Rust stuff happening. Meet the Requirement says, followed rustlings and finished the book. Nice. Yeah, I have yet to wade through any Rust books. I've been dabbling myself. Actually, Ryan, I guess a question for you is, what would be your go-to Rust book?
Oh, I think there is the book, which is the free book that's available online, written by Carol Nichols and Steve Klapnick. That's sort of it is called the book in the Rust community. It's an introductory book to the language, and if you're coming, from kind of a general programming background, that's a really great one to start with. It's free, it's online, and you can also buy a physical copy as well and support the authors of the book. I think that's a really great one to start with.
This one I got up on screen now, the Rust Programming Language by Steve Klapnick and Carol Nichols.
Yes.
Right. What I'm going to do, I'm going to drop a link in the chat to everyone. I just say it's free, but if you want to buy it to support the authors, that's never a bad thing. Cool. Chester Wick says, missed last week, but got to see the recording. Good stuff. Excellent. Glad you enjoyed it. Hopefully today should be fun. Crypto Uni says, looking forward to a future where there's WASM in the cloud and entire components exposed as FAS in Azure, all made with Rust, of course. That's lots of acronyms I don't know. WASM, that's the WebAssembly stuff, isn't it?
Yeah.
Can you do WebAssembly in Rust?
Yes, you absolutely can. And I would make the argument that if you want to do WebAssembly, then Rust is definitely the language of choice. Probably from a tooling perspective and things like that, Rust has the best support for WebAssembly, arguably, out there. I know folks who work on C# may take issue with that as well. I haven't personally tried that myself, so coming with a little bit of bias here, but definitely Rust is not a bad choice when it comes to doing WebAssembly. So
that could be an interesting stream, actually, have a Blazor person and you just arguing the case for Blazor versus Rust for WASM.
Yeah.
That could be fun. Cool. Okay, so I'm going to just crack on with diving into the problem. Actually, before I do, we just put a few links in the chat to some resources to get you going. So one of the first ones is we've got a cloud skills challenge. So we have some online learning around Rust. It's our Take Your First Steps with Rust learning module, 5.5 hours of training, all free to get you going with Rust. If you want to learn this, we have a Cloud Skills Challenge where you can kind of compete with others to see how much learning you can do in the next 24 days. 46 folks have joined in so far, and a few folks have actually completed the whole thing with other people working on it. So if you want to jump in and join our Cloud Skills Challenge, I've got the link in the chat. And if you've not touched Rust before, another link in the chat is to a series of videos getting started with Rust, kind of just going through some of the basics. What we're doing today, where we're looking at coding interview problems, we're looking at slightly more advanced scenarios. So still pretty basic because I'm very much a beginner, but we're looking at things a little bit more advanced than, a hello world type problem. So if you want to go right back to basics, the video series that's linked in the chat is a good place to start. Crypto Uni says, about books, Rust in Motion, Programming Rust 2nd Edition, and Rust for Rustations are great resources. Okay, cool. No, good recommendations. Thank you very much for those. So anyone else has got any other good recommendations for Rust content, drop it in the chat. Let's all celebrate Rust and kind of share what we've been learning. So let's just dive right into what we're looking at today. And today, we're going to do Conway's Game of Life. So if you've not come across Conway's Game of Life, it's a cellular automation. Why is my screen not sharing? I thought I shared it. There we go. There's me been talking. I've been looking at stuff on screen and people haven't been, and I haven't had everything up. So apologies. It's one of those days today. So we're looking at Conway's Game of Life today. And the idea of Game of Life, it's a cellular automaton devised by a British mathematician back in 1970, John Horton Conway. And the idea is if you have a grid of cells and you have a state in each cell that represents whether the cell is alive or dead, and then each cell will either grow or die based off the cells around it. So if it's got less than 2 live neighbors nearby, it dies. If it's got 2 or 3, it stays alive. If it's got more than 3, it dies. But if there's a dead cell with 3 neighbors, it comes to life. So it's kind of like cells dying because of underpopulation, overpopulation, or reproduction. It's kind of an interesting mathematical idea that's gone on to spawn a whole load of different things. In fact, let's just bring up okay, I'm on the spot. I'm trying to copy you. Copy that link. See if it'll work. It's not going to do it. We've actually found with Game of Life there's a whole load of weird patterns that produce animations. Not that one. There we go. I actually found that you get animations happening due to the reproduction. So whereas you've got things that just exist and don't change, things that will rotate, there's spaceships, and there's a whole lot of stuff they found that happens just from the interactions of these cells growing and dying. So that's the basis of Conway's game of life. What we're looking at today is just a simple challenge of it, which is given a board, what is the next state of the game? So we have a board, it's an n by n grid. So you've got cells by cells. And in that grid, you have cells marked as 0 or 1 for dead or alive. And then based off that, what is the next state? And kind of one of the rules of game of life is all the births and deaths occur simultaneously. So you can't go through cell by cell, calculate this cell, then calculate the next cell, calculate the next cell, because the results of that calculation will impact the other cells, if that makes sense. So we have to kind of do everything in one pass. So that's the problem we are going to be looking at today. So Ryan, have you ever built Conway's game of life before?
I'm trying to think if I actually ever have done it. I'm certainly familiar with it, seen it a million times. Have I ever done it in Rust? That I would have to say, no, I have not. So I'm excited to give it a go.
Should be fun. Should be fun. It kind of leads on a bit. So for those who joined us last week or caught the recording, we were dealing with the number of islands problem. So we had like a grid of land and sea. This is kind of similar. We have a grid of true, false values, 1, 0 values that we're kind of working on. So we're going to kind of dive a bit more into how we represent data in grids. Just a couple of comments. Meet the Requirements says, I love Rust for rustations. I mean, just from the name. Yeah, one thing I do love is the name for Rust fans is rustations and the little crab, the crustacean crab. What is the crab called actually, Ryan? The crab has a name, doesn't he?
Yeah, Ferris.
Ferris the crab. Why Ferris? Do you know?
It's a pun on I believe when something oxidizes, it becomes ferrous. That's another name for oxidization. For when something rusts, it is ferrous. So yeah, it's a pun.
Yeah, because when iron rusts, iron chemical symbol Fe from ferrous, I think is the original Latin name for it. So yeah. That is a terrible pun. I love it. So Crypto Uni says all of these are much more available for anyone with an O'Reilly subscription. Nice tip. Yes. So O'Reilly used to be Safari Books Online. I think this is called O'Reilly Online. That is a great resource. You pay a subscription fee, and all your computer books are free, and you're not buying these big paper things that sit on your shelf, and then after a few years you throw them away. I actually did that the other day. I had to clear out, throw away a whole load of paper books because they were F# 2, things like that. So, O'Reilly's great for that. Cool. Right. Let's start doing Game of Life. Now, like we did last time, I'm going to start by setting up a test environment. In fact, first thing I'm going to do is I am going to invite Ryan to join my live share. So if you've not come across live share before, what it is it's extensions of Visual Studio Code. And with this extension, I can send a link to someone else and they can then join my Visual Studio Code session. So what's happened, now that Ryan's joined, you'll see here, Ryan joined the collaboration session. Now Ryan has joined, Ryan has basically got full control over my Visual Studio Code. So Ryan will have VS Code running locally. And inside VS Code, he will see the same code I see, but he will see it in his view. I'm going to make the terminal read right. So Ryan will see it in his view. So whatever theme he's using, whatever layout he's using, he will see that. But he's got access to all the code here, and he has got access to everything else. So you can in fact see that's Ryan. I'm not. My hands are up. I'm not touching this. That typing happening in the terminal is Ryan doing it. He's got full access. But this is a really great way for folks to pair program. And he's got full access. So I'm crossing my fingers that he's not going to do anything too bad. No. But one thing that's called live share is you can control the level of permissions. So I can set the terminal to be read only. So Ryan couldn't do this, or I trust him, maybe foolishly. So I've set it to read write, so you've got complete control. So really great way to do pair programming, and especially in these days of remote work. We are in completely different continents right now, and we are working together on the same code. So I guess the first thing I want to do is I want to actually create a new project. So it's Cargo new. We touched on this last time. Cargo is the tool for managing your Rust projects, and we'll call this Game of Life. And this will create our Rust application. And in here, we have got our cargo toml, which is our metadata file, and our source code. And there we are. And you just saw the thing flash up to say that Ryan is in my source code. So for Game of Life, we want to start with a test case. We did this last time. We want to start thinking about a test case for the game. We'll build a test case, a unit test, and we'll use that unit test to validate that our application actually works. So we went through this last time. I'm just going to write the boilerplate out. Assuming I've got this right. Hopefully Ryan will be keeping me honest.
Looking good.
I will just put a fail test in there just for fun, and then go to that, and then cargo test. Oh, cargo test. There we go.
We want to change this assert instead of assert.
Oh yeah, assert. Yeah, assert false. Sorry, there we go. It still fails anyway, but it fails because we wanted it to fail. So this is our test. This is where we're going to start building up our game. So folks watching, have you ever done Conway's Game of Life? Question for you. Have you ever built Conway's Game of Life? If you have, let us know. Drop in the chat the languages you've used, what you thought about it. So this is our first example here. We want to see whether we have this state here, 0, 1, 0, 0, 0, 1, 1, 1, 0, 0, 0, and whether it gives us this state that's coming out. Now, if we look at the rules, any live cell with fewer than 2 live neighbors dies. So if we go here, this is a dead cell. This one here, I'll just zoom in a bit. This top one, number 1, is a live cell. This has only got 1 neighbor, which is this one here. And so it dies. And so our 1 becomes a 0. Any live cell with 2 or 3 neighbors carries on living. So this live cell here, for example, at the end of the second row has got 2 or 3 live neighbors. It's got 1, 2, 3, so it stays alive. It's got more than 3 live neighbors, it dies. We don't have anything with more than 3 live neighbors in this example. And then any dead cell with 3 live neighbors becomes a live cell. So if I look at this middle one, the bottom row here is a 0, it's dead. We have 3 live cells above it, so that becomes alive. So that's just kind of a walkthrough of the rules. So I think first thing we need to do is we need to implement this grid in our test case. Now, last week we were doing the number of islands problem, so we did this grid using a 1-dimensional vector. What do you think this time? Should we try doing a 2-dimensional vector just to be different?
Yep, sounds good.
Okay, so what I'll do is, so if we call this board, this is a initial state, I guess. And we want this to be a 2-dimensional vector. So we do vec bang, which gives us our vector. Then in here, we can just do vec bang, can't we, for each one. So we need, let's just copy and paste this into a comment. So our first one is 0, 1, 0. And so we just have multiple lines of this, don't we? This is how we do it. So it's just vec bang inside vec bang. 0, 0, 1. Because the last time we modeled the board as a 1-dimensional vector. This time we're doing it in 2, and you kind of get this weird syntax of vex of x of x. And I talked about last week, Ryan. This expands, isn't it? This vec bang is a macro, and this will actually expand to code to actually expand to the code that builds the vector. Now, one thing we did talk about last time, which is worth mentioning now, is we are making an assumption that our board is going to be square. So that's one of the downsides I talked about last time with this vector of vectors is we are assuming each of these is the same size. When we had our one-dimensional vector, we could actually validate it was the right size. We could say, yeah, we've got this board that's 6 by 12 and our vector has 96 elements in it. So we could validate the size. Here, I guess we could manually validate the size of each row. We're still going to have a certain level of assumption here, don't we? We're going to be assuming that each one is the same as the right size. Derek Jameson says, we did Conway's Game of Life a few years ago during a pair mod programming workshop. That sounds fun. We're live share, so we're pair programming now. But yeah, it's probably quite a cool way to do it. It's, here, can you build this together? Because in principle, it's quite a simple problem, so I can have a good pair programming exercise. Nice. Oh, Fuel Snabled here. Oh, I'm tripping over a table. Fuel Snabled, hello. Fuel Snabled has joined a number of my streams from Scandinavia, if I remember correctly. Welcome. Glad to have you back with us. Fuel Snabled says, Norway. Yes, I was right. From somewhere in Scandinavia, Norway. Awesome. Yeah, I would probably use a single vector for the matrix. So last week we did that. We used just a single vector. This week we're trying with a two-dimensional vector because, well, a vector of vectors, because we can, I guess. Good to try it. So yeah, Fuel Snabled to say from Norway, which is Scandinavia. So yeah, great to have you with us again. I've had Fuel Snabled joins a number of my streams. So it's almost like I have a fan. No, but no, really great to have you back with us. Cool. So we've got our vector of vectors. This is our initial state. And then we can just, it's all fairly dull this. We can then go through and define our end state. 1, 0, 1, 0, 1, 1. Oh, hey, nice. And then I guess we need to actually call the function that's going to calculate the next bit. Oh, thank you, Ryan. I missed the CFG test part at the start there. Thank you for that. Thank you for correcting my code. Fuel Snabled says, right now there are 4 streams I want to watch. Usually there are 0. You need to space them out a bit more. Yeah, sorry about that. Sometimes it's the way. It's well, tell you what, you let us know which ones you're interested in, and we'll try and get them organized next time. Yeah, that's always the way. Sometimes they'll line up beautifully and get a whole day watching. Sometimes just get 4 at the same time. But I'm glad you chose mine. What do they say on airlines? There are many airlines you could fly with. I'm glad you're flying with us. So yes, thank you for flying with us today. Cool. And then we need to add the actual function to do this. So I'm just going to drop this in here. And then we pass in the initial state, and then this is not initial state. This is final state. We want that. But the calculation next state is that, and then we need to do some kind of assertion on that. Fuel Snabled says, "I'll fly with you as long as you do proper maintenance." Well, as you may have noticed, Ryan's been fixing up the problems I'm getting wrong. So Ryan is definitely my expert maintenance engineer. So you are flying with the best airline right now. So Rust uses snake casing. Yeah, great question, actually. Ryan, do you want to talk about the casing standards in Rust?
Yeah, sure. So for variables and things like that, yes, Rust uses snake casing. For type annotations and things like that, it uses, Pascal casing. So every initial word is capitalized. But yeah, casing is just something, as I've learned more and more programming languages, it's just something you kind of get used to as you, and I've been doing Rust now for so long that when I see other languages do it differently, it takes me a while to get used to it again. But yeah.
Cool. So just, I guess as an example of that, we need to pass our initial state through to this here, and we have a vector of vectors. So this would be, we'll call this board, for example, and this would be a vec, which is capital V. So we've got the Pascal casing here, haven't we? And that's a vec of it's BU size, isn't it? So yeah, although we're using snake case here, but we're using Pascal case here. Fierce Neighbor says, I don't see syntax, I see expression trees. You're one of those people who can read the matrix, aren't you? Okay, and then I guess I need to do the thing, because this isn't going to give me access, is it? I need to use create.
Yeah, and I'm not sure if use crate will work here. What is more idiomatic is to use super. Super refers to the parent module, and that should work, hopefully.
Okay. I run the test. The test passed okay. It complained that we're not doing stuff. Oh, so does Rust have statements? I am so over statements.
Yes, Rust has statements. So when you, for instance, here, when you go ahead and bind a variable name through a let binding, that is a statement. But most everything else in Rust is an expression, meaning that it returns some value. But variable bindings are just statements.
Because I know in some languages, when you do the variable binding, it actually does return the value. So you can do A equals B equals C kind of thing. Yeah. It does actually do that. Yeah, this doesn't. Interesting. Meet the requirements says, do you recommend Rust for interview practice algorithms? I have doubts about fighting the borrow checker doing interviews. I guess it depends on what kind of job you're going for, really. If you're going for a job as a Rust programmer, then yes. If it's just a generic programming job, Ryan, what are your thoughts?
I think you should use whatever language you feel comfortable with. So for me, I might use Rust because I feel very comfortable in Rust. I tried to write some Python today, and I don't write Python, and I quickly gave up. Even though Python is generally a pretty, easy and friendly language, I don't know it, so it's hard to write. So I think sticking to the language that you know is probably the best way to go.
Yeah, definitely agree with that. It's obviously if you're going for a programming interview for where the language, if there is a specific language, you should be using that language when you do the test, unless the job says you don't need to know the language, we'll teach it to you. But yeah, so whatever you feel most comfortable with. So if you feel most comfortable with Rust, use Rust. But yeah, fighting with the borrow checker during interviews, going through, do I need to put an ampersand here or a star here? Sometimes it's not what you want. Ogbonakins, who says, would U8 be better here instead of usize? I mean, we're just doing ones and zeros. We could even do trues and falses and use bools.
We could also use an enum instead, alive and dead.
Yeah. So there's lots of options. So really, I think right now it doesn't matter. I mean, we're not optimizing this to the nth degree. If we were really considering, running this on like a microcontroller where memory was really important, then there's so many more optimizations we might make before we even think about using UA instead of a usize. But yes, we could use anything. We could use booleans. We could use an enum. There's anything we can use. I just use usize because, again, we had a great discussion about usize last week, actually. So if you're curious about usize, catch last week's stream on the Microsoft React YouTube channel. And we had a great discussion on there. Crypto Uni says, doesn't everything with no return val actually return a unit?
Every expression does, yes.
Yeah.
So every expression returns unit, but when you're binding variable names, that's not an expression, that's a statement, so it doesn't return anything.
Yes, I can't do this, for example.
Exactly.
Okay. Wizard says, I see Rust code for the first time. Cheers. Yes, welcome to Rust. So put some links in the chat. If you've not seen Rust before, we do have a series actually getting started with Rust and kind of right back to some of the very basics. This series, we're looking at interview problems, so kind of a little bit more advanced stuff. So we've got some great resources on the Microsoft React YouTube channel all about Rust. So one says, yep, I think that's true. Everything actually returns. Yeah, so apart from these statements, apart from variable bindings, they return. Ogbonna Kingsley says, yes, a crypto unit, but you can skip it. So if it returns a unit, you can just, you don't need to take that value and do anything with it. You can just ignore it. You can just call. You don't need to bind the output of a function call that returns a unit to anything, which is cool. Fuel Snable says, so I should stick to Motorola 68000 assembler. if that's your jam, then go for it. I would not myself. Meet the requirements as agreed. I'm just going to brush up. Cool. Yep. Can't hurt if you decide you want to do an interview problem in Rust. Then brush up on your Rust and do it. Fuel Neighbor says could use bit fields. So yes, again, if we were wanting this to be really compressed to run this on like a teeny tiny microcontroller, then you might actually store you might store this as 3 bits. So you'd have 4 different 8-byte numbers here, and store it in bits. So you could do that if you really needed to compress it down. And then, of course, should it be row or column sorted? But most often than not, it doesn't matter, I find, says Fuel Stable. Yeah, I mean, I've done it here with rows like this because it's easier to read. It kind of looks like the rows and columns that we're expecting. One says, interesting, I didn't know that bit about statements. I didn't realize that because I know with a lot of language you can do the continuous variable binding, A equals B equals C equals 4. So I didn't realize that was a statement. That's cool. Wizard says Motorola 68,000 on the Amiga. The Amiga, that's going back some. Playing Shadow of the Beast and Rainbow Islands on Amiga back in the late 80s, 90s. CryptoUni says void for return is out. Yes, I mean, void and the unit type are basically the same thing, really, I guess. And then Fuel Snable says, haven't done anything since the old Atari Amiga days. Still creating demos with all the music and the whizzy graphics that you share on a floppy disk, eh? Those were the days. So, Ryan, did you have an Amiga or an Atari?
No, I think my very first computer that I remember playing with was, what was it? The Sega Genesis or Mega Drive. Yeah, back in the early 90s. So, good times.
Nice, yeah. I didn't have an Amiga. Only the rich kids near me had Amigas. I had a ZX Spectrum.
But you're from the UK originally, right? That's a big. That's wasn't that like a BBC computer at some point that they put out into?
No, there was the BBC Micro, which is the BBC one that they put out,
yeah.
and they gave that to a whole lot of schools. So kind of kickstarted the computer science revolution in schools. But the Spectrum was the first one designed really for home. So Clive Sinclair, who passed away last year, actually, he designed this as a home computer, and it's teeny tiny, 48 kilobytes of RAM, 8 megahertz processor. You have to plug in a tape deck to it cassettes. If anyone remembers cassettes, so to plug a tape deck in to load and save programs to cassettes. Had a BASIC interpreter. I spent hours learning how to code in BASIC back when I was a young kid. It was great. Fuel Stable says, can I declare a function as returning void to indicate it should never complete? No. So if you want to return nothing, you just return nothing. I believe, Ryan, correct me if I'm wrong, but I can also do that to say it returns the unit type.
Yeah.
But it doesn't mean it doesn't complete. It just means it doesn't return anything.
There is a return type that you can put there if you mean that it will never return, as in it will loop forever or terminate, and that is the return type bang. So if you do return bang, then that function never returns. And the compiler must be able to verify that it will never return.
So if you had like a message pump inside, I think going back to the original applications where you had the message pump sitting there just chugging away, that's now built into all the frameworks. This is the equivalent of how you mark that function.
It's actually used very often in embedded programming, because a lot of embedded programming, you want to have a function like some kind of handler or something like that, where you can guarantee that it won't ever return. You'll annotate it that way. More of an advanced thing, yeah.
So I think about like Arduino programming. When you program Arduino, you have like setup and loop, and the idea is loop runs continuously. Whatever is surrounding that function that would surround that would be marked with the bang, because it would call setup and then just continuously call loop. And the idea is it would never ever exit. The only time it ever exits is if there is a some kind of hard crash, and that would reset the device.
Yeah.
So, Amiga, Atari. Doesn't anyone remember the good old Intellivision? God, that is going back some. We should do a retro console stream one of these days and get some of the old console up and try and see if we can remember how to program on a Commodore 64 or something. That could be fun. And Fuel Stable says, can I do list bang to indicate an empty list that can be cast to any other list? Because this is very type safe, isn't it? So when we do this vec bang, this is what is actually happening on the hood. Is it's looking at this type. So what's coming out has a type. I don't know why my Rust analyzer is not actually going. Is it going to go?
I think it's because you're one level above the project instead of being...
Oh, there we go.
Oh, is it running now?
Just need to restart the Rust analyzer.
Oh, nice. Oh, great.
So yeah, you'll see, if you're stable, the Rust analyzer is really cool. It fills in this annotations here. So you see, this is a vec of use size. So it has to be the type. We can't have a vec of just anything that we can cast. Is that right, Ryan? Am I speaking truly?
That is correct, yes.
Yes, if your neighbor is saying, for example, in Scala, I can say an empty list is type list of nothing. Thanks to covariance, can be cast safely to a list of string. Well, you don't really get. You don't kind of get polymorphism the same way, do you? In Rust, it's kind of more interfaces, traits, isn't it? Traits is the word. So, can you get covariance and contravariance of traits?
Covariance and contravariance are normally talked about in terms of lifetimes rather than types. So there's no inheritance, for instance, in Rust. You can have a trait that requires that another trait is implemented on the type. But as far as covariance and contravariance, it's usually around lifetimes. But that's like very advanced, and most Rust programmers never think about that. So.
But could you have a vec of a trait, and then you could put anything in it that implements that trait?
No, you cannot, because if you were able to do that, then each individual element might be a different size. So if you're putting, for instance, a Boolean, which is only 8 bits big, and usize, which is 64 bytes big, they're two different sizes from each other, and then you wouldn't know where in the array to index into, because the offsets would depend on what is in each individual slot. So everything inside of a collection has to be of the same type so that we know how much memory to actually allocate for them.
Okay, which you could, with a more dynamic language you could do, because it's designed that way, whereas Rust is designed to be very memory specific with what it does.
Well, I mean, the reason for that is in dynamic languages, what you do is you put everything on the heap, right? Everything is in the heap, and then basically when you have a list of objects or something like that, it's just a list of pointers, essentially. So every element in your array is just pointing to the thing that you want it to. You can do that in Rust as well, but you have to explicitly do that by boxing things.
Okay, and that's kind of more advanced stuff, because when you start talking about boxing, that gets scary. Crypto Uni says, perhaps add cargo expand, so you can take a look under the hood of those macros. That could be interesting, actually, yeah. If there's a way to expand what vec bang actually does.
Yeah, cargo expand is an actual tool that you can install and run. So you have to install it. You have to do cargo install and then pass in the URL of cargo expand. Or actually, you can just do cargo install cargo-expand, and it should work. And that will go ahead and download it from crates.io and build the whole thing for us. And then eventually, when that's done building, then you can run cargo space expand, and it will expand out your entire programming and program and expand out all the different macros that you've used.
Okay, cool. While it's installing, Fuels Enable says very useful for choice types. So there are option types in Rust. So you could use a vector of option types, I guess. That would work, wouldn't it? Even though they're kind of variable size depending on what's in them, but you could use that.
Yeah, but they'd have to be options of the same thing. So option of usize, option of u8. They can't be options of different types. Yeah.
But you could have the option there. So one could be none and one could be some of whatever inside there. So CryptoUni says, I think traits is generally closer to Haskell's type classes conceptually.
That's correct.
Cool. That was easy. In C# interface, enumerable out T means the interface is covariant. Yes, it means, Rust just doesn't have just does nothing. Meet requirements says, can you show us an example of boxing if we have time? So boxing is all about variables and memory. It is not Ryan and I putting on gloves and punching each other. One says we might run out of time. Yes, I think we are probably going to run out of time with this problem anyway, but we're having a good conversation about Rust, and really that's the important thing. Tell you what, how about next week we do boxing? This week we'll try and get this problem solved. Next week we'll do boxing. Fuel Snable says chat is doing best to derail the stream. Yes, it's all your fault, Fuel Snable. You're trying to derail the stream. But no, good. It's good conversation. It's good conversation. But yeah, okay. I'm not going to run cargo expand, I think, because of time, and I don't want to break all my code. Is there a cargo contract? Can I get rid of expand? No, let's not run it. Okay, but yeah, so there is cargo expand that will take these vectors and give you what's there. Right now, just say about types. Actually, quick notice about types. You'll notice the Rust analyzers guess this type as vec of view size and guess this one as vec of I32. And the reason for the difference is because I've said that the board we pass to calculate's board state is a vec of view size. And so there's type inference. So that Rust will work out the type. It'll look at this, go, board is a vec of view size. I'm passing initial state in as this board, therefore initial state must be a vec of view size. Whereas this one is kind of defaults into a vec of I32. But we can actually explicitly specify the types if we wanted to. Right, we've got 18 and a half minutes.
Oh gosh.
Right, so we need to calculate the next board state. So we need to go through the board. I guess we need to have a copy of the board, don't we? Because we need to calculate everything at once. We can't go through an update in place, can we? We want to actually go through and create a new board that's got the updated values in it. So what I'm thinking is if we just start by creating a board that's just a direct copy, and then we can go through and start applying the rules. So if this is right, so if I can go for 4. I can do this, I can say for each row in the board, because the board is a vector of vectors, and each vector is a row. So if I can do this, that will give me the index of the row. And I'm thinking, rather than use the enumerator to enumerate through, if I get the index, I can use this because I have to look at the cells around it, don't I? Yeah. That might be easy to do via index. And then if I can do for col in 0 ... row. It's not row, board row .len. So this is basically iterating through each row, and each row iterating through each column. Then I need to create an output, don't I? So this is a mutable vec of view size. So this has been my output, and this is what I need to turbofish, isn't it? That's vec colon u size colon u.
Do we want that to be also a vec of a vec, or are we making the output? Okay.
Yes, it should be a vec of a vec. Good point. So we talked about this last week. So if we want to catch the stream on the Microsoft Reactor YouTube for last week, we talked about this turbofish, why it's the coolest named and weirdest syntax you'll ever see. And so what I can do here is for each row, I could do let's new row equals vec colon u size colon new. That creates me a new row. And then in here, this is mutable, doesn't it? So again, with Rust, everything's immutable by default. You can't change it, so you have to explicitly say if it's mutable. And then in here, I can go new row dot. Is it push to a vector? Push, and I can just put. I'm just going to copy what's on the board right now. I should probably actually push down here, shouldn't I? So I do output.push, and then I can put the new row. Then I'm gonna return the output, and this is all going to complain at me, isn't it? Because I have.
Yeah, there's a few mistakes here that we'll have to fix.
Okay, right, red squiggly. Let's look at this. This is squiggly because the value is moved here. So what am I doing wrong?
Yeah, so you're creating new row here on line 9, and then you're moving new row into your output. And so now new row is inside of output, and new row is no longer usable anymore. You've essentially taken new row and you've handed it over to output, and output now owns that value. So output is over here, it owns the value, but then you try and use new row again, but you don't have new row anymore. You've given it over to output. You've given ownership of new row to output. And because of that, you can no longer use it. And that's exactly what the error message is saying. It's saying you're using a value that has been moved somewhere else.
Right, yeah, value borrowed here after move. Okay, so this is part of the protection stuff in Rust, isn't it? Because if I hand something over to someone else, I have no control over what they're going to do to it. So therefore, anything I do could break it. So meet requirement says, would making a reference be better?
I think an easy way to fix this particular problem is to just move line 10 down below the iteration over the exactly like that, and that should take care of that problem at least. So now we create new row, we do everything we want with new row, and then we hand it over to output to hang on to.
Cool. Okay. So now we've got a thing where we now should be returning what comes in. Anything else that's wrong with that? I'm not seeing any more red squigglies.
No, I think that should be fine. We might run into some fun things when we actually go ahead and implement the logic for deciding whether it's alive or dead, but we'll see.
Okay, and I guess as well, we need to do an assertion here on our test. Is there a way to assert that one vector is the same as another vector by looking at the contents, or are we going to have to go through it line by line?
You should be able to just assert that they're equal. So you can do assert equal, an initial or final state and calconnect state, and it will do the right thing.
Okay. So that will actually look at the contents of the vector.
Yeah.
So if I run this, not that, it's going to fail. Okay, because so it's saying that 0, 0, 0, 1, 0, 1, 0, 1, 1. So it's saying the left, which is this final state here, and it's actually dumped out the contents, is different to the right, and the right is as we're expecting. It's just a raw. Nice. That's quite easy actually. So rather than have to go through, I was thinking we'd have to go through piece by piece, actually go through every single one and do that. 12 different asserts here. Cool. So Fuel Stable says, so Rust does value comparison.
Yes, as in if you want to do pointer comparison, you have to be explicit about it and say, I want to know whether these things point to are the same address, essentially.
Yeah, so treats everything as a value rather than a reference type, which is nice. Nice. That's kind of quite powerful for things like this, isn't it? Because you did this in like C#. It'll go, yes, no, those two don't point to the same object. Rather you have to explicitly go and write the equality semantics in there for you. One says might be easier to push the output after. Yes, one correct. Yes, push the output after. Fuel Enable says, does it work recursively with union types and records or kind of whatever we have in Rust? So if you do equality, if you define a type in Rust, would it do equality on all the members for you?
Yeah, you have to explicitly opt into the equality operator so that it's not there by default. You have to derive the implementation or implement the implementation yourself if you want to, but you can derive equality, an equality check, and by default for union types and all various types, it basically, well, for union types, it just takes each field and compares them in turn with each other.
Nice. Yeah, because that makes it so much easier. I just get sick in some languages having to constantly write equality operators. It's just like, no, just do it. I like language like F#, which kind of does that automatically for record types. Cool. So now we need to calculate whether something should live or die, really. So should cell live? Feels very drastic, doesn't it?
Yeah.
Who am I to say whether it should live or die? And this is a ball. And so we need to. I should just return something, shouldn't I? Just get the red squiggly. So we need to pass on the board. We need to know where we're on the board. And then we need to know which cell we've got, which is the view size and the column view size.
Hey Jim, just as an extra hint as well, you typed in false here because you wanted the red squiggly to go away. That works totally fine. Another thing that you can do is to use the to-do macro. And this is really great if for more complicated code, you can write it even in a message in here, we should implement this. And if you actually were to run this code, it would panic and print that message out. So this is a really handy tool for code that's not quite complete to type in to do instead of coming up with something, a dummy value or something like that.
That's pretty cool. Okay, so we're saying, but if you can just put that back, that to do. I want to see this in action.
Yeah.
Cool. Okay, so if we say let cell equal. Let's actually get the value of the cell. This one here. Let's cell equal that, and then if cell is equal to 1, and then we could do if should cell live board row column. Push 1. I just want to actually call this push 0. So if we're live and we should stay alive, we push 1. Otherwise, we push 0. Then I'm just gonna do the same thing. It should cell die. And then if cell equals 0, if should cell die, we push. No, it's not. It should cell die. It should cell be born. Because that's what we do. It should cell be born. Which one? Okay, so if I do this, and the test is not going to hit this yet because we've got another red squiggly.
Yeah. So what line is that happening on?
It's just because we're passing it to should cell live.
Yeah, exactly. So we talked a little bit about this last time. For our functions that are testing things, we're passing ownership of the board into it. So essentially what we're doing is as we're iterating over it, we're attempting to give over the memory of our entire board over to those functions, and those functions will then have ownership of the board. If that were allowed to happen, at the end of the first call of should cell live, our entire board would be deallocated. We'd run the deallocator, that memory would be freed, and the board would be junk now. And Rust doesn't allow us to do that. So what's a good way to get over that? We don't want to pass ownership to should cell live and should cell be born. We just want to pass a reference to it. We want to let that function borrow the board so that it can look at it, but it doesn't take full ownership over it.
So this is where, so if we mark this with, was it an ampersand, isn't it?
Before the type, yeah, and not before, yeah, exactly.
Yeah, because this is saying we want to pass a reference to it, and then I mark this with the same thing, the same ampersand. So this is saying, hey, you're not actually owning this anymore. You can just have it whilst your code is running. But when your code finishes, I want it back.
Yes, yeah, you can borrow it, but I still own the thing. The caller owns the board still.
And then it's my responsibility to look at the thing in case you've changed it, because you may have made changes. So I'm explicitly letting it borrow it so I know that you could change it.
But this is an immutable reference, so in fact we know that the board will not change here. The board is
true.
We cannot change the board at all. We can only look at it.
Nice. So now if I run this, then what we should get is our errors, which is the to do.
Yep, just down a little bit more. It was down, 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 down. There it is. You just passed it by. Well, there it is.
Oh yeah, we should implement this. Not yet implemented, we should implement this. Nice, so I've got this not implemented error. It's not an exception that's been thrown by it, it's an error actually in the compiled code. Sorry, some chat comments. Ogbana Kingsley says, I think you derive from partial equal, right, Ryan?
Yes. There's partial eq and eq. There's a little bit of a difference between the two, but that's not very important for these types.
Okay. I guess assert eq works with the values in this case because it knows the unsigned type is actually U32s. Yeah, so it will go. So I guess it will go through everything in the vector and then just call eq on all the items in the vector. Yeah. So as long as the item in the vector implements eq, then it'll be able to do this comparison. Yeah. I guess assert eq works with values in this case because it knows sometimes or is that value that implements copy? Yeah, it doesn't need to implement copy, it just goes to compare to equal. So yeah, as one says, it doesn't need to implement copy, it just checks for equal. And then one says you just need to put the ampersand on 13, you don't need to own it. So this is up here. We could again put an ampersand here to pass a reference because we don't need to own it to calculate the next board state, do we?
No.
So we could do that. Good point. Is there any specific reason of why the ampersand has to be depicted before the type, or is that just how it is? I'm guessing it's because the type is a reference of the thing, isn't it? This is You're not saying the board. When we pass it, we put the ampersand in to say this is a reference to initial state, but we're specifying the type is not a vector anymore; it's a reference to a vector. So we have to kind of have that in the type, don't we?
Exactly.
And yeah, as one says, I think it's because the ampersand is part of the type, it's a reference type. Yeah. I don't think we're going to finish this one today. I think we're going to have to finish this one off next week. I got told off for running over yesterday because we have another Twitch stream that happens on the hour, and we kind of ran over a little bit into the last Twitch stream. So I don't think we're going to finish this. So I think next week is when we get to finish this all off. But we'll just want to take a minute just to actually look at the output that we've got here from running this, because we've got some warnings here. So as well as what we're expecting, the not yet implemented, we should implement this. We have some warnings here around stuff not being used. And it says, if this is intentional, prefix with underscore. Ryan, do you want to explain this? Because this is kind of quite useful, but what's the idea behind the underscore here?
Yeah, so everything in Rust needs to, things in Rust usually need to be used. The compiler won't let you sort of define a variable and then not use it. If you want to not use something, if you're just putting it there because you're not done coding, or maybe sometimes you want to just have a filler type, then you have to be explicit about it and put an underscore beforehand, which basically says, oh, I'm not going to use this thing. That's the convention the compiler holds on to, and it will no longer warn in that case. So that's an easy way for you to see which variables are being are intentionally not being used, and if they're not intentionally not being used, then you know, hey, this thing is probably a mistake. I should be using this variable instead.
Because that underscore is kind of a standard syntax in a lot of languages, isn't it? They call it a discard, I think it's in .NET, it's called a discard. So if you have a function call and you don't actually care about the return value, you can just send that to underscore equals whatever, because you were saying, make sure you call this. Because I guess with languages like Rust, there's going to be an optimizer, isn't there, that runs. So if you've got a function call that's supposed to return something and you don't do anything with return, then why do you need to call the function call? So the optimizer could, in theory, remove that. But if you're saying let underscore equal whatever, you're telling the optimizer that, no, I want this to be called. Is that correct? Or
it's the optimizer is very, very complicated. The optimizer doesn't have any insight into whether there's a side effect that's happening in the function call. So it will always call the function because it doesn't know whether it can just completely elide it or not. So I don't think it does that per se, but there are definitely optimizations that the compiler will make when it knows that variables are not being used, and can get rid of some instructions that will happen because you simply don't need to do it.
Cool. Cool. Okay, we're going to have to stop there. I know we didn't get anywhere near finishing this, so next week we'll be back on this. Thank you everyone for joining. Yeah, if you want to catch next week's stream, make sure if you're on YouTube, make sure you subscribe. And you'll get notification about next week's stream. If you're on Twitch, same time, same place, come join us next week. We put all the resources in the chat. If you want to learn more Rust, we'll dump those in there again now. We have got a survey in there. Please take a moment to fill out our survey. We want to know whether this kind of stuff is good for you, or if your neighbor's got more complaints about having too many good streams at the same time. Let us know which streams you want more of so we can make sure we space those out. But otherwise, thank you very much for joining us. Hope you enjoyed this, and yeah, join us next week where we will try and get this finished. So have a good day, everyone. Enjoy the rest of your day.
Bye.